Hi, this quick video will walk through doing EM visualization and EM circuit excitation in ADS. We have a pretty quick agenda here. I'll talk about what the differences are and then run through a few demos to show you how you do this, what you can do with this, and then how you can enable the EM circuit excitation add-on inside of ADS. And we'll wrap up with a super quick summary. EM visualization is used to visualize far fields and near fields in your passive structures after running an EM simulation. Basically what you can do is look at current densities, field intensities around the structures after you run the EM simulation. This is fairly common. Most tools do this, and all of Keysight's integrated EM tools and EM-based solutions have this capability. EM circuit excitation is a little bit different. It allows you to do the same type of visualization of the near and far field of the structure, but it also combines the component circuit models, which are typically your SMD devices, active devices, things like that that were not part of the EM simulation. And it also allows you to put it under full test conditions, so you can connect your sources and drive your circuit and then look at current densities and things like that with the whole circuit put together. So kind of unique, and you can get some different information and insights into your design doing that. So I'm going to run through a few quick examples right here, and let's start with EM visualization. Okay, so I have ADS running here. This is 2020 update 2, but these capabilities have been part of the tool for several years now. I'm just going to open up a simple design that I've done, a few traces, fairly quick and easy. You can see that there's a mesh in here, so I've already run momentum on this, and I can run the visualization tool by just going up to my menu and selecting the visualization option here. However, before I do that, let's walk through the EM setup so you see how you enable this when you run the EM simulation. It's pretty straightforward. There's just a couple things you have to look at. If I go and select the EM setup and we go to our output plan tab, notice here there's an option to save currents, and I can do this for all generated frequencies. I can do this for no frequencies, or I can do this for user specified frequencies. So we're going to say all generated frequencies. This means that every frequency point that momentum is run at, it will, as part of the adaptive suite, it will save the currents that we can then use for the visualization when we're done. So you have to make sure you have one of these options saved, either all frequencies or user specified frequencies. The next thing to look at, if I go to the model tab, notice there is an option to reduce the model size. If this is turned off, which means we're not reducing the model size, we are saving S parameter data and currents or fields for post-processing that we can then use in the visualization tool. Notice if I turn this on, only S parameter data is saved. So make sure this is turned off, and then we can run our simulation and we'll be able to visualize the results. And it doesn't matter whether this is momentum, RF, momentum, microwave, or FEM. They all have the same capability. The visualization icon is located here in the EM setup. It's the same icon that was in the layout window, so I can launch either one. But since I'm here and it's here, we'll just use this one. This launches our 3D viewer tool, and when this comes up, it will read in our design from the layout and then start reading in the solution data from the EM simulation. So let me just move this around a little bit. So there's some neat things you can do here. First of all, this is a fairly simple design, but it gives you the idea of what you can do with this. 3 important tabs here on the bottom left are the properties, solution setup, and plot properties. Let's go to solution setup, and we can define what kind of excitation that we want to visualize here. By default, it's single port, but I can go to user defined and I can set up a multi-port excitation if I want. We'll keep this at single port, and then we can define what port we want to excite. And by default, it's port 1, which is this upper left port. But if I select other ports, you'll see that it highlights them, and we can look at the fields that are going through these other lines that are connected to that port. So we'll say port 1, And then we also can choose what frequency do we want to visualize at. So you can see here there were 5 frequencies that were run in the EM simulation. Let's just choose 16 gigahertz. And now if I go to look at properties, there's a couple things we can do here that are kind of neat. First of all, we can animate this, and this starts sweeping the phase, and you can see the field densities change as it goes through this trace. If I hit display maximum field locations, it is now listing all the locations and the value of the field in highest to lowest order. So I can select the different fields here, and it will center on the screen. If I zoom in and click on these, it will keep this level of zoom and just change around. So this can be helpful for getting some insight into design. Where are you seeing your maximum fields? Where is the maximum densities occurring? That can give you some insight about what you need to do to mitigate potential problems. Also notice that when we're visualizing this, it's using the scale that's on the bottom here. And this is auto-populated from the max and min values that it finds. But we can override this, and typically I will do that. And I usually do it by a factor of 10. And that may be a little, I think it was a factor of 100. So when we go back, there we go, factor of 10. And so now look that we can see here, because we're exciting this port 1, and I have the scale turned so low that this whole line is basically pegged. But we're now starting to see the coupling that we get to these other lines. So this can show you where you have some coupling being introduced. There's some nice visual aids that you can get from this. And so basically this is visualization. This again is a very common capability that most tools have. Okay, so that was our visualization demo. Now we're going to talk about EM circuit excitation, and we're going to do 2 demos with this, one using FEM and one using momentum. So I'm going to use this momentum example here. This is actually a shipping example. So if you want to run this yourself, you can open up ADS and search the examples for EM excitation, and it will pull this example up. So this is a pretty simple setup. We have a dipole antenna here. It has a vertical and a horizontal polarization. I can descend into this just so you get an idea of what this looks like. This is the layout that the EM simulation was run on. Notice that we have, these gaps where we have SMDs or active devices that would connect across here, and we have pins in place. This is, fairly common setup that we would run an EM simulation on. After we ran the EM simulation, we brought that structure into a schematic using our layout lookalike component capability. So hopefully you're all familiar with that. That gives you a nice symbol of your structure that looks just like the layout. So it makes it very easy to wire up. So when we go in here and we place in the capacitors and resistors as needed, it's pretty obvious where this goes and how to set this up. Once we have this set up and we have our bias conditions defined, we're ready to run the EM circuit excitation. This is running a AC simulation. If I can find that right here. There's a control voltage that we are using to swap, and let's take a look at what happens when we run this EM circuit excitation right now. I have a pull down at the top. You probably do not have this yet, but I'll show you how to turn this on. If I select circuit excitation, it brings up this GUI where I can now run a simulation. Notice it has to be a DC, AC, harmonic balance, transient, or envelope simulator that we're going to run. And I do have this set up to be AC. So hit the button. This will now launch the simulation. It's telling me that I have no named node, so it'll be hard to plot voltages and data display, but we're not going to do that. I just want to show the visualization. So we run that. It doesn't take very long. It's not running the EM simulation that's already been run. It's running the circuit simulation using the EM model. It's all done. And we have a couple other options here. Once this is done, we can select the frequencies. This can be helpful. Open this up, and this will show you what frequencies the EM simulation was run at. what simulation the circuit simulator is run at. And in order to do visualization, you have to have the same frequency point for both the circuit sim and the EM simulation. In this case, we have one, it's at 2.45 gigahertz. So let's remember that number. We'll start visualization. And now I get a list of all the frequencies that I cannot visualize because I do not have the EM and circuit simulator at the same frequencies. So once again, it's going to load up the 3D viewer. This is exactly what we showed last time. Reads in the solution data, so no changes there. Has the same tabs. If I go to solution setup, again, I can do this single port, port 1, that's at the bottom here. And let's just take a quick look at this. To do the excitation, I have to choose the frequency point that is in common to both EM and circuit simulator. That was 2.45 gigahertz. That's right here. And so now I can see the excitation. Let me just go here and let's animate this. And this is typically what you would expect. So we're not showing anything different here. This is exactly the type of visualization I showed last time. And we have an energy coming into this port, and it comes up to trace and then hits this gap where we have our SMDs, active components, whatever, and it just kind of dies off. It's not going to gap. You see a little bit of coupling here, but this is normal visualization. This is what we would expect to see. But let's look at the EM circuit excitation. That's where it gets interesting. If I go back to the solution setup and go up to our port setup, we now have a new option here. It's called Extracted Excitation. And if I run this, notice now we're seeing the energies going into the port 1, up to trace, and it's now going across the gap. It's taking into account the capacitors, the resistors, the active models that are set up in the circuit level simulation to enable this full visualization throughout the structure. So this is kind of cool. This is kind of unique. And also notice we had this control voltage that was set up in the schematic. And I have the states shown right here. So I can choose different states. And let me put this down a little bit just to make it stand out a little bit more. And so you can clearly see the energies going in this port 1 at the bottom, going up the trace across the gap, and actually intensifying a little bit as it goes through. If I change to the other state, it chooses the other path to go through. So this is kind of neat. And this is also fairly unique as well. The things that this allows you to do, make sure that your design is set properly, your layout is done properly. You don't have unexpected shorts or opens where you don't want them. So you get a little bit of insight in here. Also, we can go in here and you have the same ability to display the maximum field locations. So this could be some help for reliability. Look at it, make sure that you have the proper widths and things like that to handle the type of currents and fields that will be going through this. Now, what I didn't show last time was we have other options here. I'm showing this being shaded, but we also can display this as an arrow. And this is also another way to visualize intensities. You just kind of see this explosion of arrows where we have the maximum intensities. We can also set this up to do contour plots. If I turn these off, it's a little bit easier to see. So different ways that we can do this visualization, and this is available in just the regular visualization tool and the EM circuit excitation capability. So that was running momentum. So quick example, we're now going to run another one using FEM. So let me shut this down real quick. And FEM, I have another example ready to go. This is a little bit different. This is a packaged FET device. We have arrays of bond wires coming in off our input pad. We have a AC voltage source that we're applying to stimulate this, and we can do a few different parameter sweeps in here. So once again, let's launch the EM circuit excitation. Bring brings up the GUI. We have to do this with either, a DC, AC, harmonic balance transient or envelope. Again, I have an AC simulator set up. Hit go. We're done. We're ready to go. Let's take another look at the frequencies. And you can see here we have, I did a sweep on this AC simulation, so we have multiple frequencies, and they line up quite nicely with the EM frequencies, coincidentally. There are two EM frequencies that will run that we do not have a circuit simulation run at. So for 6 gigahertz and 15 gigahertz, we cannot visualize these results, but everything else we can look at the results. So we'll start the visualization tool. And once again, it'll pull up our 3D viewer. It's going to tell us what frequencies we can't visualize. No problem. It'll pull up our visualization tool, load in the layout, and then read in the simulation results on top of that. Now, when you run this with FEM, it's a little bit different. So let's walk through this. This is kind of important. First, if you look in the lower left corner, you see we have another tab show up. We now have a sensor set up. Look at that. These are different sensors that have been placed in here, and EDS will do a kind of an intelligent guess at what the appropriate sensors would be. Their interfaces in the substrate stack up, things like that. So, for example, we can enable the Z equals 100. I click that too many times, and it's showing us the plane at Z equals 100. And this lines up with the top of these cap bars that are defined in the substrate. Also notice I can turn on the mesh by clicking the show. So if you want to visualize the FEM meshing, you can do that in the visualization tool. And it's picked, a few planes that kind of make sense to the tool. But this isn't typically what we would want to look at. So we need to add these sensors, these field sensors that make sense to us. And looking at this information in a plane is not very helpful. So we're going to add sensors. This whole metal array is going to be one big sensor. First of all, we need to go back a little bit because we have this air box defined. Run an FEM simulation. It does the full 3D structure and the whole bounding box. So let's get this air box out of the way. It's just kind of annoying. It's fairly easy to do. If we go back to our Properties tab, under this visible option, we can say All, which is the default, or I just want to look at conductors. Bingo, only our conductors are being visible. All right, let's go add our sensors now. So I'm going to say Add Sensor. And we have 3 different options here. We can select an object plane. So we click on the face of an object, and that will be extended through the whole structure to be the plane that it will use to visualize. I can say select 3 data points, and then it will create the plane that goes through those 3 points. Or we can say select object, and this is what I want to use. And now I can select an object and add that as a sensor. I can look at the currents and the fields in through that object. Now, there's a lot of bond wires here. I don't want to be selecting all those bond wires. So quick little trick here is I can turn on the connectivity checker. And anything I select here that is electrically connected will automatically highlight. So just by clicking on that one structure, I have now selected the cap bars, the landing pads, 3 different arrays of bond wires, and the input pad. And we're going to call this a sensor. Let's call it input just to be clear. And I'm going to hit Save Shaded Objects. And notice I now have to show up, and if I click on this, I can look at the meshes through the structure. Now it looks like I clicked this bar one too many times and actually deselected it, so that's not going to be visible, but that's okay. Let's add another sensor. Do the same thing. I've enabled this pen attention app so that it highlights where my mouse is and it's interfering with trying to select this. But once again, this will be fine. Let's call this our output. So notice now we can see the mesh through all these structures. Now that we have these defined, I can turn on the enable button here, and we can see the densities, the field densities in here. And now we can go on just like we would with the other ones. And again, we're going to set this to be an extracted excitation. Most of these, except 6 and 15 gigahertz, are available for us to visualize. So let's say 5 gigahertz, that's fine. And under properties, we have a couple different options here as well. So let's just hit animate. And now we're looking at just this output as it's sweeping the phase. I can go back to my sensor setup and turn on the input as well. So here we go. We're looking at the fields going through the input side of this, and then on the output side. And looking at this, it's pretty clear that the fields are stronger, they're more intense on the output than the input. And that makes perfect sense here. This is an amplifier, so we would expect to have more energy at the output. If we're looking at just a standard visualization and we're applying an excitation to this input, there would be hardly anything on the output here. So again, this is kind of a unique capability to this visualization with the circuit components under full drive being displayed. In addition to looking at this, we have different fields that we can look at. We can look at the E fields, the H field, and the J fields. With momentum, we have the ability to look at the J fields only. And again, we can look at the maximum field locations. Take a couple of seconds as it goes through all the data, and we'll then list them highest to lowest. Let's move this out of the way. So you can see where we're getting our highest fields here, and that makes sense. They're all on the output side. We also have some other options here when we're looking at this. In addition to the shaded arrow contour, we can also look at volume and boundary if you want to see the boundary between everything and between radiation, E port. So we have some other options here on how you want to visualize this when you're using FEM. Okay, so last thing we want to show you is how to enable this. How can you get this EM excitation add-on yourself? So to do that, very simple. If you go to the main ADS window under Tools, App Manager, this is showing all the add-ons that ship with ADS, and there's quite a few. You can define your own as well, but looking through this, EM Circuit Excitation, just open this up, turn this on, and you're good to go. When you first turn this on, ADS is going to tell you it has to restart, so just shut it down and open it back up again. But then from there on, every time you open up an ADS and go into the schematic, the EM Circuit Excitation capability will be available to you. Okay, so those are the examples, the demos to run. So quick summary. The EM Circuit Excitation is enabled by an add-on that ships with ADS. Pretty easy to get in there and turn that on. It works with both momentum and FEM. And this allows you to have additional levels of insight into your design by being able to look at the visualization of the currents and the field intensities with the component models in place and under full drive conditions. And that's it. Thank you for your time.